Okay, we may have an issue. So, let's see. Eric is, so Eric, can you see the little waveform on your name all the way on the top right? Because I see you sending media, but we can't hear you.
Top left.
Oh, was that you, Karsten?
Yes, the bar graph, the speaking bar graphs on the top left.
Yes. So Eric, I don't know if there's somebody else who might be able to present in your stead, because we have to, since we have a full agenda, I've got to get started. Okay, so I don't know if somebody on the Meet Echo team is here to help Eric troubleshoot, because there's no phone dial-in, Eric.
Try it from
Okay. Yes, Karsten? I've got to get started, but make your quick comment.
Yeah, just was suggesting to try it from the mobile. You may have better internet access there.
Okay, Eric will keep trying.
He's previous meeting that Eric was in, he was also having audio troubles there.
Yes, that's what he mentioned, which is why I told him to join 10 minutes before. Okay, we're now eating a minute into the agenda. So thank you for all those who've joined. This is the Remote Attestation Procedures Working Group session. Welcome. This is our second day. For RATS, we have 2 sessions. This is the first and the shorter session of the 2. It is a formal IETF session, so all of the note well content applies. I think most of us have already participated, so you are familiar with the note well. For the administrative tasks, I noted that I can do the jabber, since I will be watching the chat as well. So I can be noted as the jabber scribe, but we do need note takers. So Ned, if you can help watch the CodeMD and help with the notes, I would like to see a couple more people volunteer. And note, I can't move forward unless we get volunteers. We've got 60 some odd people on the call. Can I get a couple people to help, please? Thank you, Robin. Can I get one more? Okay, thank you. So we've got Robin, Chris will help, as so will Michael. Excellent, thank you. Okay, so we also, because we need to do a couple of consensus calls, wanted to do a hum test. So if you guys have not done this before, on the left-hand panel, you'll see like a little graph where you see the chat and the participant list. That is the hum test. And so if we can begin the hum test, we will have 35 seconds for you to respond. The question for you to respond to is, do you have more than 5 masks to protect you from COVID? Okay, let me start the hum. And so when you click on that icon, you'll see your choices. Now I can't remember all the choices. Click.
Choices are hum softly or hum loudly.
Thank you. And you don't have to hum if you don't have more than 5 masks. Okay, one more second. All right. Wow. We've got a Forte hum, so a lot of people have a lot of masks.
I told you people would have a lot of masks.
You are absolutely right. I only have, okay, I suppose I have 25 disposable ones. I suppose that would count.
Yes.
All right. Okay, so I am running out of time. So let me run this agenda bash really quick. We've already gone through the administrative tasks. Today we're focused on a cluster of presentations revolving around the network device attestations, focused on the TPM, with the pub-sub models leading to the general description of the different interaction models, if you will, for how you carry out the attestations. So unless there's any comments or objections to the agenda, we should move forward, because I'm now a minute over. Going once, going twice. All right. So Guy, you are on. I am sharing your slides.
Okay. Thank you. So my name is Guy Fedorko. I've been working on this remote integrity verification work with Jessica and Eric. We've presented this work a couple of times in previous meetings, and there's only a small update this time, so I will try and get through the material fairly quickly. Next, please. Thank you. Right, so as a reminder, the objective is to standardize the technique for using trusted platform module TPMs to report on the state of the state of integrity of low-level software on devices. We're focusing on network devices at the moment, but this is applicable to other kinds of things, industrial IoT and so on. And the point, of course, is to give network operators an opportunity to determine whether their devices are out in the network are healthy. Next, please. This is based on the background check model that is described in the architecture document. This flowchart shows the challenge response as described in Hank's interaction model. And again, that is more or less the same as the previous incarnations of this. Next, please. Our goal, there's in the topic of attestation, there are a lot of different things that one can attest. What we wanted to do here was to focus a little bit on what it is that RIV does appraise or attest, and of course, by extension, what it doesn't. The key focus is on the very lowest layer of the software stack. So checking code, credentials, and configuration of the firmware and bootloader and operating system. Next, please. And the goal of that appraisal, of course, is to ensure that the higher level software stack is in good enough shape to trust it for other kinds of assertions and attestations. Using a TPM, of course, is often focused around these so-called platform configuration registers, PCRs, which are used to record the hashes of attested objects. It's natural to tend to focus on the PCRs themselves, but it's useful to remember that the PCRs, while sometimes the value in the PCR may itself be sufficient to determine attestation or not, it's helpful to remember that the PCR in fact is a hash of a bunch of entries that are individually specified in the accompanying log file. So it's usually the log file that you're using for verification, and the PCR itself is just there to check it, to ensure that the log file has not been tampered. That's kind of a fine distinction, but in some cases we'll see later it's actually helpful. There's careful specification of some of the PCRs by TCG specifically for UEFI BIOS. There's a specification for that which has been reviewed quite carefully and is very tightly spec'd, but that covers only one case, the UEFI BIOS. And there are a lot of other operating environments out there. So there's room for additional work on narrowing the scope of what is measured into which PCR, but at the same time, we can't expect that there's going to be one solution that says this is the rule for what you put in every single PCR. So there will be vendor variability that the verifiers have to cope with. Next, please. This outlines the conventional allocation of PCRs. At the high level, there are 16 of them in the minimal TPM. The first 8 are specified, again, for UEFI, are specified in the PC client document. 0 through 7, 8 and 9 are used conventionally by the loader, such as grub2, and 9 and 10 are conventionally used by operating systems such as IMA. Next, please. This chart, oops, sorry for the small font. This chart gives the definition of what's in, a high-level definition of what's in those PCRs. And again, for UEFI, this is well and carefully specified. For U-Boot and others, I think it's not currently, but I think the guidelines are would still be applicable for that. We should note, as Eric may say later, that other PCRs may need to be allocated for specific tasks if you want to do a streaming event, since if you stream a PCR, you'll need to get every log entry that goes along with it in order to make sure you understand what's going into the thing. So again, the message simply is that there is not going to be a fixed and immutable standard of what goes in which PCR, but rather verifiers are going to have to be flexible enough to cope with different allocations. Next, please. Finally, this picture still shows again the relationship between this draft and some of the other work in RATS. Obviously, it depends on the architecture document for terminology, and Hank has been maintaining the charts of who sends what to whom in the interaction model, which is referenced in this document. And of course, coming out the other end, the Chara is the Yang implementation of how to do this TPM-based attestation, and the subscription model as well, and that forms the basis of trusted path routing. Next, please. So to finish, we do need in the RIV document another round to line up the nomenclature with the architecture. I think we're pretty close, but the architecture has evolved a little bit, and when it's stabilized and we're all ready, then we will go through again and make sure that the nomenclature is exactly in line. Some of the TCG specifications have moved forward, and I'll update the notes for that as well. So some have changed from draft to full release. But at this point, we're not planning any further substantial content. There are lots of other things one could do, but I think for this round of the document, we're going to at the moment we're inclined to call it complete. So at this point, we'll start to ask people a little more intently to review a bit more broadly.
Well,
and
yeah.
Yes.
So Guy, you have, there's about 80 participants here, including the chairs. So we could ask here now, could we ask volunteers? Well, let me ask first the question, has anybody read this draft who's not an author? And you can go ahead and just send audio. Going once.
Hi, this
twice.
is Eric. Can you at least hear me?
Yes, we can hear you now.
I'm an author and I read it, so that didn't qualify, but at least I proved I can send.
Yes, good speed test there. Okay, so so Guy, let me send out a request for review.
People to send audio.
We're supposed to send audio. We've read it, or just put our hand up.
I don't think there's a way for me to see hands up. Kathleen, can you see?
Yeah, you just request to be in the mic queue, then you'd hand your be up and you'd work.
Ah, got it. So if you've read the draft, just request to send audio, I guess.
Oh, great.
Oh, so we've got 3 people. Okay.
4. There's 4. I've also read it, but
okay.
I'm assuming I don't count.
Yeah, I mean, I've skimmed through it. I don't count. Okay.
Oh, you know what? We're up to 6 or 7.
Okay, so that's great. It would be good to get feedback. Guy, it looks like you also need to do another update, but it would be good to get feedback to see if, from a content perspective, we're ready to do a last call. So I guess as chairs, we could send that request out to the mail list. So if that can be noted in the minutes.
Sounds good.
Nancy, that would be great. Thank you.
Okay. You're done.
Okay.
All right.
Thank you for the time.
Q still, are you looking to speak?
Somebody on the queue?
Michael, I just opened it up in case you wanted to speak. I guess not. I think he retracted.
Yeah, he probably was when we were doing the hand up as to who read the draft.
Yeah, he just had toggled it a few times, so okay.
Okay. All right. And Eric, excellent. Are you still on?
Hey. All right.
Awesome.
I'm going to be talking about the CHARA model, which is the challenge response model for remote attestation. This is a Yang model, which is trying to embody what Guy was just talking about in terms of what interfaces might you want to expose to TPMs on routers and switches. And there's quite a few people who have contributed to the effort. Next slide. This is just a list of the purpose and the scope of the session. It's pretty much what I talk about. We're talking about supporting challenge response to TPMs. We're talking about getting evidence off of a device that might send information into TPMs. So it's really just trying to make sure that we have the right context, a lot of which has been described by Guy. Next slide. There's a lot of drafts that are involved, as was mentioned before, in the whole chain of drafts, from the language that's being developed with the architecture team through what Guy described in the profile, and over to the right side, which is starting to get to interface specification. CHARA is an interface specification, and there are other interface specifications which we're going to be talking about in upcoming presentations. But this just tries to show the flow of documents across the working group. With luck, you'll see this presentation or this slide and other presentations coming forward. Next slide. Now, there were a lot of issues that were addressed since the last time we met. There's issues everywhere from making sure we had more restrictive typing, such as a PCR number not being a uint8. There were issues about getting rid of identity or getting rid of strings for different types of cryptos and trying to really reduce the number of possible errors that can be induced by allowing anybody to input any string for known crypto algorithm types. And we'll talk more about that in a second. I'm not going to talk through all the issues addressed, but I'm going to highlight a few of them. And they were sent to the list, and hopefully people have also seen the items if they've checked out the GitHub repository. A couple of the big issues that we did were we simplified the access for devices that don't have multi-line cards. We got the draft ready for last call when we started to get TPM name of all and other things removed, so we didn't have catch-all items in the Yang model. And there was a request out before for things like making sure that the features for TPM 1.2 only appeared in TPM 1.2 devices, and features for TPM 2.0 only appeared for TPM 2.0 devices. So there's a number of issues that we hit. I'm going to highlight a few of them later, but any of the issues are open for additional discussions should people want to bring them up. Next slide. One of the issues I'm going to be talking about in a second is issue 8. One of the questions that came up on the mailing list is, why are we using certificate name as an identifier for a TPM? That really has to do with the keying and improving the ability to find when keys change and be able to get the information securely off of the device. We've now used certificate name as a way of validating what TPM is doing the talking. There's also additional things that we added in, such as VTPM support and links to other data stores being defined in the IETF, such as the crypto data store types and some of the key store drafts over in the NetConf working group. Now, I'm going to highlight a few issues here. If you can go to the next slide. What you can see on the upcoming slide is the Yang model tree. The Yang model tree has a couple benefits that were not there before. As I mentioned, we now don't require a compute node in order to identify a TPM. This means that we've simplified access for single TPM devices. And as I mentioned below, there's a new certificate name that is going to come from challenge response RPCs. And that certificate name allows you to check into the config tree right here to find out what TPM name is the owner of a particular certificate which is doing signing. Now we have two questions to ask today, and I'm going to go to the next slide for that. First question that comes up is, instead of strings, we now have Yang identities to identify asymmetric algorithms. And if we look at the asymmetric algorithms, there's a whole set that we could include in the draft. They include algorithms which are IETF definitions from other places that you can see in orange on the left. And since they're not in TPMs, I don't think there's a lot of reason to include them as viable algorithms for our models. There's also algorithms in red, which are non-symmetric algorithms. And it's probably not worth showing algorithms that are asymmetric in this particular Yang model. So I guess one of the questions that I want to bring to the list is, should we just reduce the set of algorithms supported in this draft to just those TPM asymmetric algorithms that are currently exposed in the existing TPM 1.2 and 2.0 standards? Now, we are able to extend this, but I do think that that we want to get feedback on the list of, should we trim the list of algorithms just to those which could be hit on these chips? And I do think that's best for the list rather than a hum question. There's also another question, question 2 on the next slide. And there is, I think it was Wei Pan or somebody from Huawei who asked for a new log type for network device boot. And we haven't gotten any feedback yet where people do want to have the network device equipped boot. But I think that we need to have some support for that from different people in the working group before we add it into the model. So if you can come, yes.
My audio dropped there for a second. So on the previous slide, when you were asking the question, you should take it up to the list, but just so you note on the chat, there were a couple of comments there. So Michael Richardson was asking whether the list of algorithms were from the Yang algorithm types draft. And Ira was suggesting to delete SHA-1, which I think we should because it's been deprecated already.
That works for me. SHA-1 goes out. In terms of the listing of algorithms, the listing of algorithms came from the TCG algorithm types that are supported from TPMs for anything in that points up to those. In terms of the IETF ones, there was a contribution from somebody earlier saying these are some of the algorithm types. So each one had a different source for where it came in. And so I'm trying to cull from multiple sources. And my assertion is that is what it is. So we can continue that on the list.
Great.
All right, so question 2 was a new log type. And again, I think we need to keep that. And then the last slide is, are there any other questions? Do you guys have anything else? One thing I think we're ready for, if people are okay after this, is I want to submit this for the Yang doctors review. Prior to going to last call, the Yang doctors should start to engage on the draft. And I think it's ready for that request if other people agree.
Jones.
I see somebody in queue.
Yep, I'll let Mike through. Okay, Mike, you can speak.
Hi, Mike Jones from Microsoft. The question about RSA with SHA-1, I will point out just for reference that for the W3C web authentication work, where there's TPM attestations, they did choose to list the RSA SHA-1 algorithm. And in fact, the COSE working group is just finishing a draft that registers that. Now, it's a deprecated algorithm, but because particularly TPM 1.2 uses it, we did want to make sure that it was usable, even though in an ideal world, we would prefer that people had moved on.
All right, that's good input. One option we could have is just to allow it for TPM 1.2 and not type it under TPM 2.0. So if that's the preferred answer, that's certainly supportable by the Yang definition.
Michael Richardson in queue, so I'm going to let you through.
I don't think it matters if an algorithm is deprecated. I think you should, if there's a device out there that can support MD4, then by golly, I think we want to know that it's using MD4 so that we can declare it as not sufficiently tall enough to play, right? So I think it's really important that that anything that's reportable by a real device that was ever made should be in the list of things there. That doesn't mean that the appraisal policy has to accept it.
There's one other thing that we can mention. If you can go to slide 6 quickly. the open question that we have, or what types are allowed as identities, on slide 6, the second line down, you'll see supported algos. A customer supporting the model with the model can list just the algorithms they want to support. So there's the identities in the Yang model that are viable. There's also the list that are allowed for a particular device. So just because we allow it doesn't mean the customer cannot shut it down by not including an algorithm under supported algos, which is the specific list of what are viable on a particular platform.
So it may be useful for you to clarify allowable from the notion of a control. That's where I'm getting confused, which is why I was saying, well, SHA-1 is deprecated versus reporting. So I can see the argument for including that you want to report anything that's being used or capable, but from the controls, that was my comment on the chat, that SHA-1 is deprecated. We should not allow the use of SHA-1 where there is control.
All right, so I think a good way to do it would just be to put under supported algorithms that we recommend not allowing SHA-1 to be configured as allowed, but that's up to the user. So there's a difference between the identity list and which ones we want to support, which is that second line. And that I can cover it in the Yang model by just adding that clarification that it's not recommended in the description.
Okay, so we have Roman in the queue,
Okay. Kathleen?
and we are out of time, so
Yes.
so we're going to cut off the queue after Wei Pan.
Hi, Eric. I just wanted to clarify what you just said to kind of Nancy, but because I think I was going to make the same point. The idea is that we want to potentially encode the insecure algorithms because some version of TPM in the past supports it, and we want to be able to expose that. But we would provide appropriate language in the security considerations or other kind of processing guidance to suggest that this should be low confidence information, and we might want to handle it differently because of that confidence. Is that right?
Absolutely, and we also have the ability to allow, a customer has the ability to allow or not allow which algorithms from the chip are there. So we have a couple different ways of doing both protections in the text, as well as the list of supported algorithms for a platform being configured in that list I pointed to earlier.
Okay, so that's perfect. So then I would say that it actually becomes important to be able to encode the insecure algorithms just so we can make the right security decisions as you're suggesting here. Thanks.
Yep, exactly.
Let's keep it very short. Go ahead.
Okay. Hello?
Wait, Pat,
Yeah,
we can hear you.
Wayne.
Okay. I have two comments. First, it's about the issue 8. I think I strongly suggest to consider to use the TPM name as the identifier, because if you use the certificate name as the identifier, but when the attester presents a new certificate name and the verifier doesn't know this certificate name, the verifier needs to do our full query to the attester to query all the certificates of all the TPMs. So I think this can be solved by using the TPM name as an identifier, and further discussion can be taken to the list. And the next is about the issue 14, and also is a question 2. I like the way to use the new log type is based on EMA, and it's how do you say, it can be seen as a fashion of EMA to measure the boot progress. So this is a new log type, but it's not the same with the EMA log type. And I like to the working group to consider move forward this one. Yeah.
All right, 2 real quick answers, and then I can wrap up. on the certificate type, it can continue on the list, but if you get a new certificate, you're going to have to go to the Yang model tree anyway to prove that it's the right one. So we don't save anything. On the log one, if anybody else wants it, yeah, definitely let's add it. All right, I think that's it. Just trying to wrap up here.
Yeah, I mean, so Eric, we're running 5 minutes over, and given that they cut off the meet echo, if you can keep yours to under 10 minutes to allow him to have also less than 10 minutes.
I can do that.
Thanks.
All right, next draft is about event stream subscription. Next slide. This is about improving what we do with Chara. Chara is challenge and response. The problem with Chara is that you don't know if there has been a change in the security posture of your router. You have to send a RPC to get the latest information. That does not allow you to react very quickly when you have a problem that needs to be worked on immediately, and that's what this draft is intended to do. This draft is the result of the integration of draft IXIA as well as section 5 from the trusted path routing document from last time. And so the entire purpose is to allow you to go ahead and get challenge response information, get rid of it by having a telemetry stream of security information. Next slide. This is just showing before that we have the same inputs to this draft as before. It is very much based on the Chara draft. We're just extending the Chara draft in a couple key ways. Next slide. As I mentioned before, we're trying to move from a periodic polling or a model where when we extend a PCR in a tester, that we have the information acquired via challenge response. And we're trying to move to streaming events as they are pushed off the system. And this allows you to do new things, such as when there's new software installed, see the information from the PCRs right away, get new types of attacks covered, like privilege level escalations as they occur, again, without having to wait to do an RPC. Next slide. Next slide is just a mapping of the notifications that are coming out of what we're calling an attestation event stream. You subscribe via RFC 8639, which is Yang subscription to an event stream that is meant just for attestation events. And what happens is you get the results of the PCR extensions as well as the attested information as it occurs. As you can see in the slide, one of the things that's neat with the TPM2 is you can use a difference in the timers from when the evidence was generated at the first query and the difference of from the second push, and be able to prove that the evidence is fresh even without the sending of a new nonce for each challenge response. So I see a question from Dave.
Hi, Eric. Can you guys hear me? Yeah, my question is, the first line that's shown is shown as originating going to the attester, and the question is, how does it know who to subscribe to? Is there some line that's missing, or how does that work?
We're taking Chara as the starting point, so you still have to go and understand from Chara who you're subscribing to. There's no discovery mechanisms defined here. It starts from the point of view as if Chara knows who to go to, the subscriber knows who to go to.
Yeah, I guess the reason that I ask, and maybe there's text in your document, I don't remember, but I think I've asked this before, is let's say the attester just rebooted, right? You're not going to get a stream of stuff until you subscribe, and you're not going to be able to subscribe until you know when to reconnect, and so there's going to be some delay where you're losing some streams.
All right, there's a couple ways to handle that. One of the ways is that with a subscription, there is keep alives based on the type of transport, both with netconf and HTTP. So we do know when that goes away. Additionally, you can use configured subscriptions, and when the thing reboots, you'll automatically reestablish. So that typically would be handled at the transport layer.
Okay, we need to move on because you're running out of time.
All right, let me move on. Slide 6 is the Yang attestation event stream. As I note, there's a number of notifications which are just pushing in a notification what you'd normally get out of a challenge response. And you are able to replay notifications so that when you come online, you can get all the events automatically that occurred since boot. Next slide. Basically, what we have is extending Chara to figure out what attestation key should be used, what PCRs are subscribable, the maximum delay to bundle evidence, and a heartbeat, as was mentioned before. You want to have a heartbeat for what your keep alive state is to prove your PCRs are in an expected state, because you don't want to miss events being pushed. And last slide. I guess the question is there interest? Please let the mailing list know. And I don't think we're ready for an adoption call yet, but I'm hoping that people will be interested in an adoption call at or before IETF 109. So any other final questions? I know I'm low on time.
No, we don't have time for questions, Eric, because
right.
we need to give time to the interaction. So I suggest you take it out to the mailing list, ask for interest, solicit feedback, and we can look for next steps. All right?
Thank you.
Great, thanks. All right, Hank. Are you there, Hank?
Well, yes, I am.
Great. Do you really want video, Hank?
No, I can. All other meetings had them. Force of habit. Sorry. Hi all. Yeah. So this is about the aforementioned reference interaction models. These are currently not part of the architecture. I issued an email beforehand, and we have new authors. So that is the summary of the introduction slide. Next slide, please. So we now enhanced the interaction model draft with the 3 typically used interaction models we find in RATS and outside of the IETF actually today. Chara has been mentioned a lot. It's an acronym for Challenge Response Remote Attestation. That's a thing typically initiated by the verifier using nonce, yada, yada. You know about that. I think I would just reiterate it. This is used by the before mentioned highlighted drafts, but there's also a tiny, easy to understand and quick to implement proof of concept implementation for challenge response using CoApp and CBOR. Look at that. It is using the relatively cool, I have to say, a library from Lawrence, CBOR library that is QCBOR. And it is at the moment only based on TPM implementations. We are really looking forward for a TEE and create some EATs at some point. Then the second one, there is an addition, which is the general model of time-based remote attestation. There are examples for that in the architecture appendix. It's relatively straightforward once you got it. There was a significant update to the text that uses for the TUDA implementation, for example, it uses now architecture language. So that's the one where you can simply send unsolicited evidence to a verifier, and that will be okay. No nonsense required at all. You can also simply get them via RESTful operations. And again, you don't have to convey a nonce in the request. And then there's a hybrid about this. Basically, if you want to have this point in time that is basically time-based, you do, that you establish this epoch, especially. It's basically a request response that is a subscription, and then everything gets pushed to you. So no nonsense after that, but the thing that you get is a reused point of time. There are also things that are using this right now. I think the one by Frank is timing out, so that is being replaced by the subscription to network devices draft that just was presented by Eric. So these 3 things are now illustrated, sorry for being here, in the model and the ID itself. They all come with really fancy and human readable sequence diagrams. There you've seen those before. I think by Guy's presentation, there was a derivative of it using timestamps and a specialization of that. Other drafts do it the same way, and that is why this ID exists. It is because all the other solution drafts and even the profile drafts use the same way to do interactions. And there was a lot of hands and forth how this really looks like and how this works. And now we came to the conclusion that it is really beneficial to have a single point to highlight the fundamental basics, how protocols or profiles or approaches even are defined by this. Next slide, please. And then there is a new addition to this ID. There's something called direct anonymous attestation, and peer reviews of the slides told me, wow, this is way too complicated to explain it in a single slide. I'm sorry I kept the slide because we have now two authors. This is Liquid and Chris from Surrey University. Basically, I would like to say the inventors of direct anonymous attestation. It is basically attestation not by a single attester, but by a group of attesters, and you cannot distinguish who will send. So there's a K anonymity here. You need enough large group of attesters to be anonymous in that group, but there are procedures to do that, and this is basically using group signatures and a join procedure and all small little additions that can, and that is the important thing, reuse the current architecture. It's absolutely fitting into the architecture point of view. No new roles, no new conceptual messages or such. There is but a single new duty to the endorser, and that is a DAA issuer, because you cannot use the credential of a single attester because that's not anonymous. You have to have a new thing that is a DAA credential that is issued by this DAA issuer. That's the only new duty defined in the scope. Otherwise, it's directly comparable to the architecture, or it's fitting and mapping to the architecture. And most importantly, it can reuse the existing interaction models. And that's basically an amplifier to see how these interaction models actually are universal, even with different concepts than the classic attestation, where you can, at the first step, always identify the attester quite well. And that is not so good for privacy in some scenarios. Please read the content here. I could go through the slides, but again, it is a little bit complicated to read the first time. I think the most important labels here I have to reiterate are group signatures. It's about classes of devices, and the group has to be big enough in order for it to work. I can have kind of questions about this later. I'm not looking at the chat right now. It's because of time, I think, running a little bit through these slides. Next slide, please. So this was the question I finally restated on the email list. We had a rather good understanding that these are good questions. I was posting them in the moratorium time to see how should this content be covered. There were this, hopefully there are now well-known options of each model in an own draft, all models in a single draft, all models being added to the architecture or going to an appropriate solution ID. There were already a few preliminary answers, and I would like to involve chairs here right now, because I'm not really sure how to proceed with answering these questions here now. My assumption is that we have to answer this one in order to move the corresponding ID either forward or choose another option. So this is basically now involving the chairs here. What do you think?
You're asking us as chairs or
yes.
as individuals? So we started the discussion on the previous session, I recall, to see if there was interest on this. We had discussions in that, as you've already noted, Hank, there are a couple of drafts that are already defining instances of these models. So it's fine. I just want to make sure we don't get cut off from Meet Echo because our time's about to expire. I think the first question is there merit in having a general discussion of the model or models defined? And so I would ask that first question, and then from there, it's the question of the options as you've listed. And so I haven't looked at the responses since yesterday. I know that there was some preference to the others, but in the interest of time, let's take these questions to the list to confirm. And so I guess as chairs, not I guess, as chairs, we can formalize the questions so to help you move forward. How's that?
Yeah, that would be excellent. I think we can build on the existing question. I recapped context and everything. So maybe deriving now procedural questions from that would be, I think, in order.
Yeah.
So that was a very, very fast forward through these slides. And Michael has a question.
Okay, we're out of time.
Ask objections for each model. I cannot live with model option blah 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 rather than votes for.
Say that again, Michael. I could barely hear you.
Ask for objections, as in I cannot live with option 3 rather than I prefer option 2.
Okay. Okay. So before we get cut off, I think that was all of the agenda that we wanted to cover today. Unless there's anything that's really quick, we again have a full agenda tomorrow. Okay. I think Michael just expressed his opinion of cannot live with option 3. Okay. So with that, before we get cut off, thank you everyone for participating, and we will continue tomorrow, bright and early, for me anyway. Thank you, everyone.
And thank you. Till tomorrow.
Yes.